Now that we've looked at functions and determining whether a relation is a function, also being able to write equations from functions, we're going to kind of put that all together and take a look at something called a linear function. This we've studied before, and it's a function whose graph is non-vertical. It's a non-vertical line because you can't write a function or a vertical line in the form of y equals mx plus b. So into our slope-intercept form. So when we are using a graph to write a linear function, we are literally taking it and we're going to say, okay, I'm going to look at this. I'm going to use y equals mx plus b. And I'm going to see what is my slope of this line, what is my y-intercept. So my slope, if I'm just going to do simple rise over run, so 1, 2, 3, 1, 2, so 3/2 x, and then my y-intercept is right here at -3. So the equation for this line is y equals 3/2 x minus 3. So we can actually take and create a specific function called that linear function by putting it into slope-intercept form. So if we have a table that shows a relationship between x and y, we can write it as that linear function as long as you have a consistent change in x over change in y. You can do that. So if you're looking here, your change in x is +1, +1, +1. Your change in y is -2, -2, -2 as you keep going. So you see how we have that consistent change in x and that consistent change in y. We can use that and we can say, all right, I'm going to write a linear function, not just a function, but a linear function that relates y to x. So again, it's going to be y equals, well, remember to do your slope, it's your change in y over your change in x. So here, our change in y is -2, consistently -2. Our change in x is +1. So to write that as your slope, it's -2 over 1, which we know is definitely just going to be -2. So change in y over change in x, so you're going to have -2x. And then your y-intercept, where that line crosses that y-axis, is always where your x value is 0. So right here is your y-intercept. And that's going to be at +3. So you can take a table and create a linear function with it. We learned this on the other lesson when we were just writing functions. We can do it from a graph. We can do it from a table. Okay, so let's take a look at the next piece. We can compare linear functions, so to real-life situations here. So if you see a problem that says the earnings, y in dollars, of a nighttime employee working X hours are represented by the linear function y equals 7.5x plus 30. Table shows the earnings of a daytime employee. Which employee has the higher hourly wage? Write that function, and then we can graph that function. So here we can see that each time your hours increase by 1, so +1, +1, +1 for this employee, their earnings increase by $12.50. So 12.5, 12.5, and 12.5. So which employee has the higher hourly wage? Well, in that instance, you're kind of looking at it as being employee number 1. Their hourly wage is going to be $7.50 because right here, your slope is what your hourly wage is. X represents your hours that you work. Y represents the money that you earned. So to decipher the first employee's earnings, when you have y equals 7.5x plus 30, what that means is that this person gets paid $30 regardless. Like that is their pay. It doesn't matter how many hours they work. They earn that $30. But for every hour that they work, they earn $7.50. When you look at the employee number 2 here, employee 2, 1 hour worked earns them $12.50. 2 hours worked earns them $25. They don't get that set pay that this employee gets. They only get that $12.50 an hour. So who's got the higher hourly wage? Well, this table here shows that of the daytime employee. Therefore, the daytime employee has a higher hourly wage. So the daytime employee's earnings, if you're writing that as a function, y is going to equal your change in y over your change in x. So your change in earnings over your change in time. Okay, because that's your earnings over your time. So earnings over time is going to give you that 1250 to 1. I just wrote to x. So it's going to give you that 1250 per hour. Okay, so we can graph these then. What I would do is I would graph them on a graphing calculator, and you're going to be able to see at what point does your daytime employee earn the same amount as your nighttime employee. So we can compare graphically two different earnings. We can compare through a chart. We can compare through an equation, and this guy up here, and then we can also compare graphically the difference between their earnings, and you can actually see where they earn the same exact amount, and then when one surpasses the other and earns more than the other. So if you're going to look here, if manager A earns $15 per hour and receives a $50 bonus, the graph shows the earnings of manager B. It says write a linear function that represents manager A's earnings and a function that represents manager B. Well, if manager A earns $15 per hour, so again, we're going to have earnings equals $15 per hour plus that $50 bonus. Taking a look at B's, well, you can see here at 0 hours, he earns $0. So again, just like the other employee, he doesn't get that base. He doesn't get that bonus or whatever it is. He gets nothing. So his y-intercept is definitely going to be nothing. You can see here then, he earns $75 in 3 hours. So that means if he's working per hour, he's going to earn $25 per hour. Forgot my y equals. So manager B gets $25 per hour, but no incentive, no bonus. So who has that higher hourly wage? Well, manager B does. He makes $25 an hour. But then if you went to graph this, you're going to notice at one point, employee B is going to earn more, even though employee or manager A starts off greater. Okay, manager A starts off here. Employee or manager B has a higher slope, has that greater slope. Therefore, at one point, he is definitely going to earn more than this manager. So, it's going to be right about here that they cross each other if we were to actually graph this. And then manager B surpasses manager A in hourly wage and earnings. So we can look at functions as being actual linear functions that create this line, that create this straight line. They have this specific relationship where you can write it as that slope-intercept form. So y equals mx plus b, as long as it's not a vertical line, because we know that vertical lines are represented as x equals a, whatever your x-intercept is. So that's your vertical line. So it can't be written in that form. So that's why we say that a linear function can be written in the slope-intercept form.